Okay, we're going to finish out this problem concerning fatalities, highway fatalities. Again, we have mu, or average number of fatalities per year, is 1,550. Sigma, or standard deviation, is 300, and we're assuming normal distribution. The question says, for a year to be in the upper 5% with respect to the number of fatal crashes, how many fatal crashes would have to occur? Again, you draw the curve, but now the nature of the problem is changing. We still know that the mean is 1,550 on the x-axis, and we know that its equivalent on the z-axis is 0. But now we want to know, what is that x value? That's what we're looking for. The question mark is that x value that is associated with the upper 5%. So we want this area to be 0.05, and we want to know at what point on the x-axis does the number occur, does the number of fatalities occur, so that that is the upper 5% of the fatalities. To solve this problem, we need to find the associated z value for this x. That is easy to do because now we know the area to the right of that point is 5% of the area under the curve. So that means that the total area to the left of that point would be 95% of the area under the curve. Or we can say that this part right here is 0.95, which is 1 minus 0.05. So because of that now, I'm going to come to the table, and I'm going to look for within the area now. Now I'm going to work the table inside out. I'm going to look for an area in here which comes as close to 0.95 as possible. So as I go through all these entries, I find that between 1.64 and 1.65, the 0.95 falls between that. So for z value of 1.64 and for z value of 1.65, the two entries are 0.9495 and 0.9505. So that my number that I'm looking for falls in between them because it's the same distance away. If you use your calculator and calculate the difference, you'll see that the 1.645 that I'm going to use falls exactly in the middle of these two numbers. So I'm going to use that. So I'm going to find, I found this z to be 1.645. So then I'm going to use my z formula, which is z is equal to x minus mu over sigma. Now I know my z, 1.645. X I'm looking for, that's my unknown. Mu I know is 1,550. Sigma is 300. So I'm going to solve for x. X equals 1.645 times 300 plus 1,550. So I get x to be 2,043.5. Rounding, because these are fatalities, we cannot have half a fatality. That'll be 2,044. So if number of fatalities in a year is 2,044 or higher, then that would be a bad year. That would be a year where we're in the upper 5% of the possible number of fatalities, given that number of fatalities are normally distributed with a mean of 1550 and a standard deviation of 300. I hope you find this helpful. Thank you.